Hello viewers, this is Wagda Renal taking you through today's tutorial for O-level physics, and this tutorial we're going to talk about electromagnetic effects. Now these are the very questions I left in the previous video, and I believe by now you're ready to try them out and ready to mark yourself and check your progress. So we are going to start with question 6, and this question came from UNEB 2016 paper 1 question 49. So part A says that figure 12 shows a trolley carrying a magnet and moving at high speed towards the coil. The coil enters and passes through, so the trolley enters and passes through the coil. So this is figure 10, this is figure 12, this is the trolley, and this is the magnet on the trolley, and this is the coil. So here they say that explain what happens to the trolley and the galvanometer as the trolley enters the coil. So you see that the trolley slows down as it enters and the pointer on the galvanometer deflects. Further, we shall say that the pointer deflects because an EMF is induced in the coil as the magnet on the trolley approaches the coil. So that explains why the pointer deflects, but also I have to explain why the trolley slows down. So we shall say that by Lenz's law, the induced EMF acts in such a way as to oppose, not that word, as to oppose the source, hence the trolley slows down. So basically that's what they wanted, and let's see how much can be awarded. So what happens is that explanation for why the pointer deflects and also explanation for why the trolley slows down. So basically that's how the 3 marks could be got in such a question. Now let's go to part B of the very question. So part B says that a 12-volt battery is connected to a 3 ohm resistor. Calculate the current flowing in the circuit. So first of all, you have to know that V is equal to IR. We know V is 12 and R is 3, therefore when you substitute, you shall be having only I as an unknown, and when I make I the subject, I'll come up with my current as 4 amperes. So basically that's what they wanted, and that's how you can get the 1 mark on this part. So that was question 6. Now let's go to the next question. So now we shall go to question 7, and question 7 came from UNEB 2000 paper 1 question 10, and part A says state any 2 factors which determine the magnitude of EMF induced in a rotating coil in a magnetic field. So one is the strength of the magnetic field, next will be the number of turns in the coil through the field, next will be the speed of rotation of the coil, and also the cross-section area of the coil. So any 2 of these, you get yourself the 2 marks. Now let's go to part B. Part B says that explain why soft iron is preferred to steel in making electromagnets. So you can say that this is because soft iron produces temporary and strong electromagnets, while steel produces weaker electromagnets whose magnetism is permanent. So that's how you can get the 2 marks in this part. So now we shall go to question 8. Question 8 came from UNEB 1995 paper 1 question 10, and says that a bar magnet is placed in the Earth's magnetic field with its north pole pointing in the geographical west as shown below. So this is the north pole of the magnet and is pointing in the geographical west. Now Roman 1, they said, on the diagram, draw the lines of the resultant magnetic field around a magnet. So those will be the field lines which they wanted in Roman 1. So we have a mark for the field above the bar magnet, have a mark for the field below, have a mark for the field on the left hand side, and have a mark for the field on the right hand side. So basically that's how you could get the 2 marks in Roman 1. Now Roman 2, they said, mark the neutral point on the neutral point X on this field line. So we shall come and see that will be the one of the point. So this is one of the neutral point, another one is here. So basically that's what they wanted in Roman 2, and that gives you the 1 mark. So basically that was part A. Now let's go to part B of the very question. So part B says that the diagram in figure 11 shows a straight wire connected to the terminals of a center zero galvanometer. When the wire is moved vertically upwards out of the plane of the paper, the galvanometer deflects. Roman 1, in which direction does the galvanometer deflect? So you see that the galvanometer deflects to the right, and with that you'll get yourself 1 mark. So Roman 2 says, why does the galvanometer deflect? So you come and say that this is because current flows through the wire due to the EMF induced in the wire. So that is also 1 mark. Then Roman 3 said, state one way in which the deflection of the galvanometer can be reversed. So one shall say that by moving the wire vertically downwards between the north and south poles. Alternatively, you can also say that by rotating the magnet through 180 degrees and then lifting the wire upwards. So any of the two, you'll be able to get yourself 1 mark. So basically that was question 8. And that brings us the end of this tutorial. So what I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of questions, but this time they'll be on mutual and self-induction. So that brings us the end of this tutorial. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the video with the solutions has been uploaded. Otherwise, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we all benefit as a family.